Stored cryogenically, this advanced composite material requires strict temperature control. The automated system
The automated analysis confirms the structural homogeneity of the prepreg material, clearing it for Process A.
The thickness is within the accepted variance range, suitable for the structural brackets.
Only material passing this high threshold is permitted for the main wing structure, preventing potential material failure during high-stress flight operations.
This strict separation confirms the process separation lock, highlighting two distinct workflows using the same raw material base.
All right, the comparative analysis is complete, routing the wing panel to Process A.
Roger that. Water jet alignment complete. Process B initiated for the brackets.
Laser alignment check complete. Panel positioned.
confirmed. Initiating hydraulic seal sequence.
The temperature is stabilizing right at 180. Ramp rate looks good.
Confirmed. The delta wing probes are showing uniform readings across the mold.
Depressurization sequence holding nominal.
Confirmed. Thermal stabilization complete.
The specialized gantry system ensures a clean separation of the 6-meter delta wing panel. It will now be transported for non-destructive testing.
The robotic arm meticulously scans the surface, ensuring the extreme aerodynamic smoothness required for supersonic flight performance. The delta wing panel enters the cleaning station, where robotic spray nozzles apply a specialized solvent.
We are seeing full cure in under 3 minutes on this section.
Significantly faster than the traditional bake cycle, as predicted.
The robotic orbital sander uses extremely fine grit abrasive material to gently smooth the primer layer.
The panel is gently moved on a rail system into the massive oven structure, and the heavy doors seal shut, initiating the low-temperature baking cycle.
Crossing the segregation line now. Beginning the automated scan sequence.
The bracket separates cleanly, revealing its flawless surface. The technician inspects the intricate shape,
The specialized jig ensures precision as the multi-spindle robot drills the carbon fiber brackets simultaneously.
Carbon fiber brackets are subjected to high-pressure solvent jets and ultrasonic removing residual swart.
As you can see, the adhesion is perfect with no structural defects. The composite is void-free, validating.
In process B,
Per the manifest, these structural brackets are confirmed for the Mirage 2000 build. Process B is complete.
Confirmed. We'll take accountability.
As part of the curve analysis, the glossy black glossy bracket seems the carbon bracket is silicon.
The integration sequence for the carbon fiber mounts looks correct.
Agreed, but we need to verify the alignment of that forward process B component before the next stage.
The bracket's lightweight, rigid design isolates sensitive electronics from vibration and shock. It's
Harness secured, all brackets checked.
Confirmed. Ready for panel installation.
Systems check on the hydraulics bay.
Confirmed. Pressure holding steady. Moving to avionics.
The technician verifies the tightness of the fasteners, ensuring no movement during high G maneuvers.
The focus here is on the internal weight savings achieved by the glossy black carbon fiber structural brackets, enhancing the jet's agility and performance.
The Mirage 2000 banks sharply, demonstrating the extreme G-forces absorbed by the carbon fiber structural brackets, paramount to safety and performance.
The bracket remains pristine, showing no degradation despite years of high-stress service. This confirms
The technician removes the component, highlighting the bracket's rigidity. The etched part number confirms traceability, ensuring efficient long-term maintenance and sparing.
Another perfect run. The stability from those structural brackets makes all the difference.
The Process B brackets show no delamination after all these cycles.
Confirmed. The material flow analysis was accurate.